This is the Module 7 video number 1 for Secondary 2 Honors. We are going to talk about simplifying rational expressions. Okay, so first we need to know what is a rational expression. A couple of words that we need to know: term, and that would be a number, a variable, or the product of a number and variables. So for example, 3 would be a term. Negative 2x squared, that would be a product of a number and a variable. Or we could just have a variable like a b to the second power. Those are all terms. A polynomial would be a monomial, like what all of these are up here, or it could be the sum or difference of monomials. So 3 plus x is a polynomial, 2x plus 4 is a polynomial. When we talk about rational expressions, usually what we're talking about is we're talking about a polynomial divided by another polynomial where there's a variable in the denominator, and that's how you can tell that we're talking about a rational expression, usually that we're going to have a denominator that's going to have something like that. Okay, so you already know how to simplify some rational expressions, and so for example 1, we're just going to do something simple that you already know how to do. 15 over 40, you've learned various ways to do this, but to explain this I like to go back to our prime factors. So if we say 15 is 3 times 5, and then 40 is 4 times 10, you could write it all out in prime factors. The reason I like to do this is because we're essentially doing the exact same thing when we simplify rational expressions. So we look at our factors, and if I see common factors with top and bottom, I can say 5 divided by 5 is 1. So they cancel. And so what we have left is we have 3 on top, and then I can multiply these back together, and I get 3/8, and that's my simplified rational expression. Example number 2. We need to first simplify the numerator, and so that's something you need to look at. Can you simplify the numerator? So we've got 15 divided by 5x. Now we're not done because we have to make sure it's simplified. So simplified means there's no common factors with numerator and denominator. So I'm going to again break this down into factors, and so I see 3 times 5 on the top and 5 times x on the bottom. So 5 divided by 5 is 1, and so since I'm multiplying I can do that. And I just have 3 over x left, and that would be my simplified rational expression. So these are the same thing, but one is simplified and one is not. Okay, example number 3, what I'm going to have to do is I'm going to have to find the factors, and so we use factoring to do that. So if you look at just your numerator, and that's a good practice to just look at your numerator, do what you can do, look at your denominator, do what you can do, and then start putting things together. So if I just look at my numerator, I can pull out a greatest common factor, a GCF, and say 5 goes in there, and I'm left with x plus 2. What that gives me is 2 factors for the numerator. I've got a factor of 5 and a factor of x plus 2. X plus 2 is one factor. It's not 2 different factors, and so you need to remember that those go together, so you can't separate them at any time. Then on the bottom I have 5 times x, so the denominator also has 2 factors, 5 times x. So when I go to see what can I cancel, I'm looking for common factors. So I have a factor, and a factor, and a factor, and a factor. So what do I have in common? It's this one cancels with that one. So 5 divided by 5 is 1. I'm left with x plus 2 divided by x. A common mistake people will make here is they'll say, oh, I can cancel these. You can't do that. It's kind of like if you had 53 divided by 5 and you just wanted to cancel the 5s. You can't do that. 5 doesn't go into 53, and so that's why that won't work. So you can't simplify just by canceling terms, and so a good phrase to remember is that you cancel factors, not terms. And so since this is one factor on the top and this is one factor on the bottom and they're not the same, I cannot cancel them. Okay, so some things to remember as we go on. You cancel factors, not terms. You need to see what can be factored and then factor it. So you're going to have to use your factoring skills here. You're going to cancel only factors that match, not terms. When you're all done canceling, whatever you can cancel, you have the option to multiply any remaining factors back together. So on our first example, we had 3 over 2 times 2 times 2. Now, of course, on that, you would want to put 3/8 because it would be silly not to. We'll see some other examples where you can or not. It doesn't really matter. So example number 4, you look at this polynomial on the top and you can factor that. So it's a trinomial, and so you think about how you factor a trinomial. So we're going to put it into 2 different groups there. So x times x is x squared. For the 6, I can do 1 times 6 or 2 times 3, but I have to figure out which one's going to work with my signs. Turns out that 1 times 6 will work because they have to have different signs, and the larger number has to be positive. So that's my factoring. When you're factoring this, if you don't factor it correctly, everything else is going to be wrong, so make sure that you get that right. It wouldn't hurt to check. X times x is x squared, x times 6 is 6x, negative 1 times x, and negative 1 times 6, and so that when you simplify that, you make sure that you've really got what you think you should have, because if you don't get the right factoring, you're not going to have the right answer. Okay, on the bottom, we are going to factor that. Now this is a difference of squares. If you notice that we've got a perfect square, subtract a perfect square, and so if you remember how to factor that, I can factor into x plus 6 times x minus 6. Now let's notice that on the top I have two factors, x minus 1 and x plus 6. On the bottom I have two factors, x plus 6 and x minus 6. So I can't cancel just the x's. It would have to be as a group. You can't just pick what parts you want to cancel. So the x plus 6 is the same exact thing as the x plus 6 down here. So x plus 6 divided by x plus 6 is 1. I cannot do anything with the x minus 1 and the x minus 6 because they're not the same. So I'm left with x minus 1 over x minus 6, and that is my simplified rational expression. Okay, next, this is a monomial divided by a monomial, so I can just break it down into factors. You don't necessarily have to write it out like this, but I like to do this to show what I'm doing. And so I'm looking for things that are in common. So 2 divided by 2 is 1, and 3 divided by 3 is 1. And then I've got all of these x's that match up. And so what I've got left is 1 times 1 times 1 times 1 times 1 times 1 on the top, and 1 times 1 times 3 times 1 times 1 times 1 times 1. So this is equal to 1/3. Okay, example 6. When you have a binomial or any kind of polynomial, you need to look to see if you can factor it. So I'm going to look for a GCF here, and I can see that 2 and x is the greatest common factor. So what do I have left is 2x minus 1. So notice that I have three factors on the top here. I've got 2 as a factor, x is a factor, and 2x minus 1 is a factor. Then on the bottom I have 2x, so two factors on the bottom. So what can I cancel? I can cancel 2 divided by 2 is 1, and x divided by x is 1. All I have left is 2x minus 1. Okay, next, if you want to pause this and see if you can get this one right. Okay, you should have factored 3 times y plus 1 over, on the bottom it's a little bit more complicated because you can notice that it's a difference of squares at the beginning, or you can take out a GCF at the beginning. It doesn't really matter. If you did 4 times y squared minus 1, you might think, well, then there's nothing to cancel. You have to make sure you've factored everything completely, and so that denominator can actually be factored into x or y plus 1 times y minus 1 because it's still a difference of squares. Then on the top we've got 3 times y plus 1. Now 4 could be broken down to 2 times 2, but there's not really any point to that because I can see that there's nothing on top that would cancel with, so I'm not going to worry about that. Y plus 1 divided by y plus 1 is 1, so what I have left is 3 on the top, and then 4 times y minus 1 on the bottom, and that would be my simplified rational expression. Okay, the last example for this video, we're going to simplify by factoring on top and bottom. So the numerator, that's a little bit harder to factor, so if you want to pause this and take a minute and get that factored, and then factor the denominator and see if you can get this right. Pause it. Okay, what you should have done is you should have factored this into 2x and x, and then the 4 is going to have to go on this polynomial over here, because if it went right here, then you would have a GCF, and since there's not a GCF here, there cannot be a GCF there. So when I have that, I'm going to have this 1 here, and then if you look at your signs, everything's positive, so you can't have any negatives there. It will have to be that. I would double check that to make sure you've got it right. 2x times x is 2x squared, 2x times 4 is 8x, 1 times x, and 1 times 4. And so I'm going to have 2x squared plus 9x plus 4, which is what I started out with. On the bottom I'm going to have 3 as the greatest common factor, and I'm left with x plus 4. And so on the top I've got 2 factors, on the bottom I've got 2 factors. I can cancel this factor with this factor, and I have 2x plus 1 over 3. And that's what I have left. Okay, now you should be able to complete 1 through 21 on your practice worksheet. So what you'll have to hand in is you'll have to hand in the notes with these examples, and then you'll have to hand in your practice worksheet. It's pretty long, and so we're not going to have the guided practice, but you're welcome to come and check your answers as you go on this if you'd like to, and get some help if you need to.